Good afternoon, everyone, and welcome to the Office of Chief Technologist inaugural Technovation Forum. Today, assessing the Ideas Cloud with Karim Lakhani. I would also like to welcome all of you joining us through the web and at our NASA field centers. Before we get started, one more time, please, just a reminder, please either turn off or set any electronic devices and other noise makers you have concealed on your bodies to vibrate or off, so it won't interfere with the presentation. That'd be much appreciated. After the presentation, we'll be taking questions beginning here with our audience at NASA headquarters. We'll be taking questions from NASA field centers and through folks that are watching on the web through email. I understand we might be having a little bit of communication problem out there, so we'll be concentrating on the email questions from both the centers and from folks watching online. You can submit your questions by email during the presentation at derek.wang-1@nasa.gov. That's DEREK-WANG-1@nasa.gov. We'll be throwing that up on the screen during the presentation, so you'll be able to see that periodically also. We'll try to get to as many questions as we can during the next hour. Today's presentation and Karim's slides will be available later on the Chief Technologist website. That's at www.nasa.gov/OCT. We'll be throwing that slide up also too during the presentation, and so you'll be able to see that, and the complete presentation will be available online. Some of the slides today might be a little quick, the type might be a little small, so you can access them online at your leisure later. Again, thank you all for joining us today here at headquarters and out in the field. And to begin our presentation, I'd like to introduce the Deputy of the Office of Chief Technologist, Mike Gazarek. Mike?
Well, good afternoon and welcome. Welcome those here at headquarters and those at the field centers. This is a great time for this talk today. Because, as you well know, the budget was released. President's budget request for 12 was released just this week. And if you looked at that, you've seen that the President's focus is on innovation, is on education, and on building the rest of the world. And so a talk on that is extremely relevant to what we're doing here in the Office of the Chief Technologist. The Space Technology Program, which is managed by the Office of the Chief Technologist, is very much in alignment with this focus on innovation, education, and outbuilding the world. The new direction, the Space Technology Program is establishing the groundwork to generate a sustainable space program through innovation and technology, and we think that's the key to doing that. So we're striving to become leaders in research and development and improve our ability to innovate and to think and do things differently. So in doing this endeavor, one of the great ways, of course, to get better is to look for some new perspective and for some help and ideas from outside our organization, and that's what brings us here today. Ideas are everywhere, of course, not just within NASA, and we're always looking to gain and improve our insight into those other ideas from other organizations. So what a great way to kick off our inaugural Technovation Forum, but to talk about that today, and to talk a speaker who has experience in technology and innovation, and is welcome to share and is willing to share that with us. Our speaker today, who will kick off this seminar, is Dr. Karim Lakhani, Assistant Professor at the Technology and Operations Management Unit at the Harvard Business School. He specializes in the management of technical innovation and product development in firms and communities. His research is on distributed innovation systems and the movement of innovation activity to the edges of organizations and communities. He has extensively studied the emergence of open source software and their unique innovation and product development strategies. He has also investigated how critical knowledge from outside of the organization can be found and put to use inside for innovation in a variety of different fields. He is also the co-editor of Perspectives on Free and Open Space Software and co-founder of the MIT-based open source research community and web portal. There really isn't a better way to kick off this series of talks and seminars So please join me in a warm welcome to Professor Lakhiani.
Thanks so much. I really appreciate it. I was trained as an engineer, and I never imagined that I would be at NASA giving a seminar. I mean, it's a real thrill to be here and to present some of my research and some of the ideas that we have to this audience. Outside of the NASA bubble, people still think of the space program as this amazing initiative. When I talk to my 6-year-old daughter about the fact that I'm going to be at NASA and I'll be sort of talking to people that are involved in the space program, there's just her eyes light up, and she's so thrilled to see that her dad is going to be here and talking to you. So again, it's a real pleasure to be here and to share some of the ideas. Before I start, I do want to acknowledge that just as I'll be talking about ideas from the outside coming in, I want to acknowledge some people that have worked with me that have helped me create this presentation. And a lot of people have been my co-authors. So I want to recognize Lars Bo Jeppesen at the Copenhagen Business School, Kevin Boudreau at the London Business School, Eric von Hippel at MIT, Andrew King at Dartmouth, who have been essential collaborators with me in creating this material. As well, 2 people, Jeff Davis at Space Life Sciences in Houston and JSC, and Jason Cruzan, have been key supporters to bring these ideas in within NASA as well. So if we can go to the first slide, we can start there. First slide any second. Before I start, I just want to take a quick poll with you about how you use knowledge today. So in the last week, how many of you have actually used Wikipedia to go get some bit of knowledge? Okay, so almost everybody in the room. Last week or last month, you went to Microsoft Encarta to get knowledge, information. Oh, one person, okay. Last week, last month, last year, went to Encyclopedia Britannica to get something. So 3 people, yeah. So if you think about it, in the space of 10 years, how we access knowledge and how we produce knowledge has been radically transformed. So in the late 90s, when the internet boom was happening, there was a book put out by colleagues of mine at the Boston Consulting Group called Blown to Bits. And the seminal case study there was how Microsoft Encarta came in and blew away Britannica's business model. Right? And what happened was that Britannica was selling, trees, right, to you in books, and Microsoft came in with plastic CDs, and they basically made a shift of the medium in terms of how knowledge was being transferred and being consumed. Then 2001 shows up, and Jimmy Wales and his colleagues start up Wikipedia, and Wikipedia again moved from CDs to the web. But also there's a fundamental transformation. The transformation was that how they produce knowledge was inverted. Instead of one centralized organization going out there and commissioning editors, and those editors commissioning authors for the knowledge to be produced, Wikipedia came in and sort of said, no, we can actually get anybody in the world to participate with us and create any bit of knowledge that's necessary and change anything around. And that's a very radical perspective on how we think knowledge should be produced and collated and put out there. And now, as we've sort of seen from this audience by itself, that just this transformation has sort of seeped throughout how we sort of consume and produce knowledge. And to some degree, the thoughts I'm going to show you are related to sort of rethinking how we organize ourselves for innovation and how we can get ideas from the rest of the world to help us in our own innovation missions. Next slide, please. So before I do give you some modern examples, I want to take you back 300 years. So sort of solving the toughest problem facing countries 300 years ago. And the example here is that in 1707, the British fleet sank off just south of the UK, off the islands of Scilly, due to bad navigation. Okay, and this was a major issue in terms of the fact that they knew there were bad rocks around the Isles of Scilly, but the fleet got lost and they were grounded, and they lost 3,000 lives in this one incident. Next slide, please. So then the British government set up a prize. The Parliament set up the Longitude Prize. And in 1714, they said up to £20,000, which even today is a lot of money, but in those days was even a lot more money. If anybody can come up with the method to find the longitude at sea, they will then give them money. But it has to be a working solution, right? Not just a proposal, but a working solution. Next slide. Now, this gentleman, Isaac Newton, inventor of gravity, the guy who you've been fighting along for your whole lives, right? Brilliant scientist, calculus, gravity, amongst other things. He had a perspective. He said that the best way to solve this problem, right? The best way to solve this problem was through the methods of astronomy, right? He was an astronomer. He looked at the stars all the time, and from that he said that the best way for us to find the solution is through astronomy. And he was actually part of the board of the Longitude that was evaluating solutions that were coming in. And he put out this pretty firm statement: nothing but astronomy is sufficient for this purpose, and it's the only right method, right? So if you're in the British Parliament, you have Newton, right, who is a polymath, who's a genius at that time, recognized as such, telling you that the only solution that's going to happen is going to be astronomy. A lot of investment is going to go into astronomy. In fact, that's what happened. Next slide, please. And we call this approach of trying to sort of solve a problem with what you already know, your knowledge that you already have. We call that local search. That you're searching in knowledge domains that you already have access to, that you know about a lot. But even though he had emphasized the astronomy solution, the British government still set up this prize. And next slide, please. And then a whole range of solutions came through. So about 100 solutions were proposed. Some were quite outlandish, right? So somebody proposed telepathic dogs, that you could somehow have dogs that were telepathic, and once you were at a particular longitude, they would bray and they would do that. Others had a great idea that what we should do is place cannon every 100 miles in the ocean, floating decks, manned somehow, and then at noon they would fire. And if a ship was nearby, they would know that we're at some kind of a longitude there. The other solution was, a pretty practical one, which was to actually make a chronometer or make a watch that could actually keep track of time. So if you knew the time at shore and you knew what time it was by sun, you could then triangulate and find your longitude. So this was a well-known solution, but nobody could actually think about a way to create a chronometer that could keep track of time on sea. So remember, we're in the 1700s. There's lots of humidity, lots of changes in temperature as you're going on a vessel, and no clocks were good enough to be able to do that. Next slide, please. The solution did arrive eventually by this chronometer, this cabinet maker, John Harrison. So John Harrison was unknown cabinet maker. He creates the device. And the reason he could create the device is because he understood materials. So he was an early material scientist. He understood how to make cabinets fit really nicely, right, in the changing climate conditions of the UK, be able to sort of weather the changes in temperature, both in terms of wood, but also metal as well. And he used that knowledge to create the chronometer that eventually solved the problem for them. It took the British Parliament 30 years to give him the award because they didn't believe it. Right? They didn't believe it. They tested this in Bermuda. It took a while for them to accept the solution. But in fact, in the end, there was through a decree of the king, basically, he was awarded the prize. Next slide, please. So what I'm going to cover are a set of topics that sort of bring us to sort of thinking about why we want to access the Ideas Cloud and the logic behind accessing the Ideas Cloud. The reason I call it Ideas Cloud is you've probably heard of cloud computing as a way to access sort of computational resources from outside the organization. That's sort of the buzzword in the tech world these days. And so cloud computing is a metaphor that many people are comfortable with. And so this Ideas Cloud is the same aspect, which says that core intellectual resources for an organization can sit outside of the organization, and we need to find ways to access that knowledge from the outside. Next slide, please. And I'll start with something that is anathema to most CEOs, which is, when I sort of talk about this in front of executives that come to HBS, they're like horrified. Like, how could it be that no matter who you are, most of the smartest people work for someone else? Right? And I know at NASA too, there's lots of smart people, and I'm sure the administrator might cringe if I said, there's a lot of other smart people outside as well of NASA as well. But let me ground this for you with some real data and information. Next slide, please. So this is Professor Bob Langer at the MIT. He's an institute professor. He's a certified smart person in many ways. So he's, youngest person to be elected to the National Academy of Sciences, the National Academy of Engineering, and the Institute of Medicine at the same time. Over 600 patents, over 1,000 scientific papers. One of the largest biomedical engineering labs at MIT. So really smart guy. And let me show you how smart he is. Next slide. This looks at his publication history in one field of medicine and tissue engineering. He's here in the green. And this shows his co-authorship relationships with other prolific publishers. So this maps 25 articles in a 2-year time period in tissue engineering. And what it shows is that not only is he a prolific publisher, he's also connected with lots of other prolific publishers in the field. So really smart guy by any dimension that we sort of think about in terms of this field of biology. Next slide, please. But this is the real world of tissue engineering. So in the same 2-year period, there were 17,000 authors with 6,000 articles also contributing to the world of tissue engineering. Lots of knowledge out here, right? And so even though Bob's here, right, and there, he's a really smart guy, there's also lots of knowledge that he does not have access to, right? And if you were to sort of think about, we need to find a way to solve a problem in tissue engineering, on average, you should go to Bob. Right? On average, you say, I want to go to Bob. But there are a standard deviation out, 2 standard deviations out. You may not think that he's the right person for us to go after. Okay? Next slide, please. And so the causal explanation, like why does this phenomenon that Bill Joy talked about, why does it exist? The reason is 2 perspectives. One is from Hayek, who basically said that knowledge is unevenly distributed in society. Okay? And this was the reason why the market economy was set up, basically, that no one central planner can organize knowledge. So we want other people to come in and give their own signals, and then that's why we will decide what the right prices are for systems in economist perspective. My advisor at MIT, Eric von Hippel, has also shown that knowledge is actually sticky. Right? Sticky in the sense that it's actually the locus of innovation shifts to where the stickiest. So it's actually hard for us to move knowledge from one place to the other place. And oftentimes what we see is that users end up being bigger innovators than manufacturers. So in the world of commercial science and technology, what Eric von Hippel and his colleagues have shown is that in fact lots of innovations come from users first. So if you think about medicine, right, doctors actually out-innovate firms. Firms come back later and come up with the ways to nicely package these things. Next slide, please. So when we think about innovation and when we think about how to deal with this problem of distributed knowledge and this problem of sticky knowledge, we want to start thinking about how to manage the process of innovation together. And there's 2 key dimensions. When you're innovating, you have to both generate a bunch of ideas, and you also then have to find a way to select these ideas as well. Okay? And both of them require knowledge. Okay? You need to have knowledge of what the different options need to be, and also knowledge of how to select the right idea. And I'm going to come back to this notion later on. But when you think about managing the innovation funnel, you say, we want lots of ideas, we want lots of diverse ideas, and then we'll have a different way to sort of sort through them, and then in the end, come to a produced product or service that comes through. So this notion of diversity of knowledge, diversity of perspectives is really important as we sort of think about an innovation process. Next slide, please. Also, if you think about this innovation process and the funnel that I showed you, is when you are thinking about innovation, what you are not concerned about is the average value. What you care about is the extreme value, right? What you care about is the highest performing idea that exists, right? And this is sort of a conundrum that you face actually within NASA, right? Operationally, you want to actually reduce the variance. You want to actually get high mean, but reduce the variance. When we're playing with ideas, when we're playing with knowledge, when we're thinking about innovation, we want to increase the variance. You want to go to the extremes and find a way to get the extreme value that exists. And the only way we can get this distribution, the only way we can sort of observe this distribution is if we have lots of people participating with us. You have lots of multiple attempts on the same problem happening concurrently. Next slide, please. And here's a reflection from another great innovator, Edison, right? Talking about the light bulb, right? Before I got through, I tested no fewer than 6,000 vegetable growths and ransacked the world for the most suitable filament materials, right? So if you remember that distribution, he went through the entire distribution, right? He observed the entire distribution and then found the right material in the end, right? You know, I didn't fail, I just discovered 9,999 different ways not to invent the light bulb, right? You need to find ways to bring out this distribution one way or the other. Next slide, please. So what we are observing out there in the world, and this happened historically, right, with what we saw with the British Parliament and the Longitude Prize, is a revival of ways to access knowledge so that we can both increase the volume, but also the variety of ideas that an organization can get access to. Next slide. The one sure way to organize this is through competition. So you basically think about running a tournament, think about running a contest, and here the approach is we think about is if the innovation problem that we have at hand requires a diversity of approaches. You want lots of different people thinking independently and coming up with great ideas independently, right? Then you would run a competition. Here, the contributions tend to be substitutes, right? So if they're all trying to solve the same problem. The way you organize it is through arm's length contracts and through IP regimes that sort of say that you transfer the IP once somebody wins. What we call is that most people are driven by what we call extrinsic motivations. They care about the prize money, they care about the fame, and the reward that will come if they solve and become the winning person in a competition. The other way it is organized, next slide please, is through a collaboration, okay? And here, again, the Wikipedia model, of course, stands as a great collaboration. Also open source software. So if you think about, again, the ability of open source software to come in and completely change the software industry and enable Google to exist, enable all these new startups to exist because they can leverage all these open source tools, it's pretty phenomenal what's happened as well. And again, with open source, what we see is that when the innovation problem requires lots of cumulative knowledge building, you need lots of iterations and lots of ways in which you can put together diverse ideas, then you would resort to a collaboration approach, an open source approach. The contributions range from mixing and matching to co-production. They're actually working together hand in hand. The governance tends to be fairly norms-based and informal. You set up communities, and communities govern themselves. The external innovators, of course, are cooperative. And here they're driven by both intrinsic motivations. They enjoy the problem-solving process, working with others, or also extrinsic motivations because they get career options and so on. And again, if you think about it, a great example is a company like IBM, right? IBM is the biggest patenter in the world, has the largest patent portfolio in the world, right? But they're also the biggest contributor and participant in open source communities, right? So they've been able to figure out how to both leverage these communities, bring the knowledge from the outside world into their core products, right? But then also create a very powerful IP portfolio as well along the way. They're not in conflict at all. Next slide, please. And this is a bit of an eye chart, but this basically shows you that sort of the ways to organize yourself through a collaborative community and markets exist together. So you as an organization have a choice. You can run contests and you can run communities as well. A good example that I always use is SAP. So SAP is a German ERP software company, right? And they have figured out how to use markets, right, to create platforms and create products that sit on top of their core platform, but also communities as well. So they have a robust 2 million strong software community that is continuously innovating, coming up with new ideas and solving existing problems for the users, for the system integrators, and for the firm itself as well. So what we see are in the commercial world that organizations have said, this is such a great way for us to think about how we can bring knowledge into our organization that we can do both simultaneously. Next slide, please. A key question people often ask is, why would anybody do this anyway? Like, why would somebody participate in these sorts of things when there's no guarantee of reward, right? And there's no guarantee that my code will actually ever be accepted at all in an open source community. Like, this seems kind of crazy. Especially when I talk to B school students, they're like, this is not like us. I go, yeah, exactly, they're not like you. There are different types of people in the world and they have different motivations. So why is it that these people participate? The thing that they come back to us when we've done surveys of both communities and competitors is that creativity. People find that these problems help them think more creatively, right? Oftentimes, it's finding the right problems that people are searching for. And when I'll give you examples later, when we've done this with NASA problems, people are so excited saying, wow, this is a really cool problem, I want to participate. So this creativity notion comes through quite a bit. What we see is people say they do it because they enjoy the process, because they think it helps them build skill. It's the freedom to choose what they want to work on, and they might even have a particular need for a particular problem. What we find is that increasing knowledge is the biggest benefit. People say that I'm learning so much along the way that this is why I participate. They volunteer significant amounts of time, on average about 20 hours per week, 15 hours per week in an open source community. And in contests, we see close to about 40 hours per week people committing to work on these challenges. And they tend to be professionals, right? So the view of open source developers were that most of these were kids at MIT who had lots of free time and they were participating. When we've done the surveys, in fact, most of them are grown professionals, lots of education, participating in these things. They have a strong identification with the effort. So whether that be making t-shirts, whether that be contributing to NASA, they identify a lot with the cause. And part of what this is going to make you do if you go in this route is to actually say, how do we confer the NASA community beyond our employees? How do we sort of make the NASA label available to other people so they can identify with it and work with us as well? It tends to be a very global effort. You'll see evidence for that soon as well. And what we see is that it's a pure leadership model. People care about it because they can sort of be there not on credentials, but on their abilities and what they have actually contributed to. Next slide, please. So contests, as I discussed before, are historically important and currently popular, right? So the Duomo in Florence, right? The dome was built through a contest, right? Brunelleschi, who was a goldsmith and not an architect, came up with a design of a completely unsupported dome. We talked about longitude, food canning as well, right? Invented by somebody who's not a scientist, but found ways to preserve food. You, of course, know about the X Prize. Incentive, we'll talk a bit about later. And even as far distance as making cars. So there's a startup called Local Motors. They're based out of Arizona right now. They are making cars through competitions. And they've been able to basically reduce the time to build a car and the cost significantly. So they went from design to prototype in 18 months for $3 million. All using communities and competitions to get this done. So it's pretty remarkable what's going on, even in very complex engineering tasks. Next slide, please. So let me give you a modern implementation of this. There's a platform called Incentive, which NASA has used. I'll give you an example of that shortly, where basically the notion is R&D labs and firms have problems they can't solve. They go to this broker called Incentive. They post these problems for a prize. Then Incentive has accumulated about 225,000 independent scientists from around the world to participate. People then self-select, decide to participate, and then if a solution is acceptable to the organization, prize is transferred, IP is transferred, and it's all done. What's interesting is that this is all blinded. So most firms don't advertise who they are and what they're posting problems from them, and then they also don't get to see who are the submitters. Next slide, please. So this was a NASA pavilion set up on an incentive under the leadership of Jeff Davis. It was multi-center pavilion. Next slide, please. There were about 12 challenges posted over time, and 2,900 solvers from 80 countries participated in helping to solve NASA problems. Okay? Next slide, please. And the challenges range from data-driven forecasting of solar events to simple microgravity laundry system as well. So real problems facing the space program being put out there. The colors show you that basically who the centers were and what the status of the prize award has been as well. Some were partial awards given. It helps crack the problem in a way, but not completely, so NASA decided to give them money for that. In some cases, like the data-driven solar forecasting of solar events, the problem was solved completely. And algorithms were created that are now being assessed and evaluated so that ground-based observation can be used to predict solar events. Next slide, please. So two central questions here. When you think about a contest, right? The thing you want to understand is, like, how do we figure out which problems get solved, right? What's happening in these communities that help us figure out which problems get solved? And in my research, what we found is that the more heterogeneous the scientific interests of the competing pool of solvers were, the more likely the problem got solved. Okay? So you want diversity of approaches, right? And that actually helps predict which problems get solved. Secondly, what you want are specialists. What you want is a physicist attacking a biology problem, right? You want a chemist attacking a math problem, right? You want lots of specialists in the pool of solvers participating. Next slide, please. And when we look at what explains who creates a winning solution, who are the winners, we get two counterintuitive findings. The first one is what we've sort of seen as technical marginality. Is that when we examine all the people that submitted solutions and we look at who won, what we've discovered is that people say that if the problem was outside their domain of expertise, the further the problem was outside their domain of expertise, the more likely they were to become a winner. Right? So it's basically somebody coming in from physics and solving a math problem, right? Somebody coming from biology and solving a chemistry problem. Okay. Now, of course, it's a straight linear relationship in the regressions. There's probably an inverse U relationship here, right? That if you were way far off, the likelihood of you solving the problem is going to be low. But what happens in these systems is that there's a lot of self-selection, right? People sort of look at the problem and they go, "Oh, I've got a shot. I think I can find a way to create a solution," and then that's when they participate, right? If they think that they're going to be too far away, they don't even show up along the way. The other thing we discovered was this notion of social marginality, where we've sort of seen that at least sociologically, women have been pushed out of the natural sciences in many ways, and that actually in our regressions actually showed that as being a very significant predictor of being a winner. So women participated less overall. They were less likely to participate, but when they participated, the odds of them winning go significantly up. Two things are going on probably. One is this notion that men are overconfident, right? That men, there's all this finance research showing that in a household, a woman should be managing the portfolio, not a man, because men are overconfident and they're going to take too many risky bets, and overall outcomes are going to be worse off. So it's that men are overconfident that they apply more in droves. That could be one. The other explanation is that, in fact, when women get pushed out of the natural sciences, they're not caught up with thinking in the normal ways of the scientific disciplines. And so then when they look at a problem, they can look at it with fresher eyes, and that's when they come through and make the solution come through. Next slide, please. So that's giving you a perspective on using science, a platform like an incentive to solve science problems. We've also, with NASA, done situations where we're actually solving pretty complex algorithmic problems as well, software problems as well, from a platform called Topcoder. So an incentive is based out of Waltham, Massachusetts. Topcoder is based out of Connecticut. And what they do is similar to an incentive. They'll take problems from firms, software problems from firms, chop them up into little pieces, and from there, they will then run a tournament around it as well. And again, big scale, 200,000 software developers are signed up and participating. About 10% at any one time are active. Next slide, please. It's a global footprint. So what we see, this is looking at all the people that participated and won contests around a sample financial services application for a large mutual funds company. Okay, so about 112 people from around the world wrote bits of code that got integrated into creating this, probably an application that you guys use, some of you guys use to manage your 401ks and so forth as well. Next slide, please. So the thing to worry about when we're thinking about contests is this inherent trade-off between sort of the incentives and extreme values, right? So if you're a contest organizer, right, what you want are lots of people participating, right? That's what I showed you. I showed you the normal distribution, and the idea was you want lots of people participating, right? But from a contest, a person playing the contest, that's actually really bad, right? So if there's two of us participating, right, the odds of one of us winning is going to be 50%. If there's 100 of us participating, the odds of any of us winning is 1%, right? So economists have come back and said that, in fact, we want to restrict entry, right? We want less people participating in a contest because incentives drop off. And using Topcoder data, we've analyzed about 6 years worth of their contests. What we discovered is, in fact, this negative distribution. That basically this shows you the slope of what happens to performance when just one additional person is added to a contest. And this is a negative slope, and it keeps getting steeper and steeper as you go across the board. The max value does go up, but not as much, right? So this is actually a real puzzle, right? Because you as a sponsor will say thousands of people should participate, right? But the person saying, oh, no, only me, right? Or my friend, that's it, not everybody else in the world as well. So this is a real puzzle. Next slide, please. So what we have investigated is, what happens with the max response if we sort of think about the problem in a creative way. Is there something about the problem itself that allows us to sort of see if that mediates this response? Next slide, please. One more, please. Yes, and so what we find is that once you account for the problem, right, and we were able to look at these Topcoder problems and say and discover that in fact, if problems required knowledge from multiple domains, so if it was an algorithm problem that required both string parsing and graph theory, then basically the effect of multiple competition, of multiple competitors is lessened, right? So the incentives shift up. People aren't as much concerned now about the high intensity of competition. And then the max value also goes up as well. So when we think about tournaments, when we think about contests as a way to organize ourselves, then what you want to focus in more on is this max response based on multi-domain problems. You want really complex, really uncertain problems to be put on there and not just very simple problems. Next slide, please. Next slide, please. Okay, so I want to bring you back and end with a 2x2, just so that, I'm a business school professor and we do 2x2 matrices for a living, so it's important for me to end with that, otherwise my dean will be very unhappy. Right, so we're back to this generation and selection perspective, right? That remember, when we're innovating, we got to generate a bunch of ideas, we need knowledge about ability to generate lots of ideas, and also knowledge to know when to pick the right idea. What's the right idea for us to pick? Next, please. So what you can do is you can create a 2x2, right? So you can think about solution knowledge on one axis, and you can take a perspective that says, is our perspective on the solution knowledge, is it concentrated in one domain, in one organization, or is it widely distributed? Okay, so where will ideas come from? And is it going to be basically in one domain, or is it going to be in multiple domains? And think about the use knowledge or the selection knowledge, our ability to pick the right answer amongst these multiple domains. Again, is that going to be concentrated, or is it going to be distributed? Okay, and so in most settings, what we say, right, when I talk to NASA scientists, right, microgravity, nobody else has microgravity. Of course, we have the best ways to generate all the ideas for microgravity, right? Right? And because we're the only ones that experience microgravity, we're the best ones to also, right, be able to select the right answers as well, right? Sure. But there are many ways for us to think about the problem, and if you open up your perspective, say, in fact, there are many ways for us to go and define this problem, then we can actually go to a distributed perspective. If we say that this problem may be existing in other domains, in other areas, right, and other people may have knowledge for us, then we'll go to a distributed perspective where we'll run a tournament, like Incentive, like Topcoder, where lots of people will generate ideas for us, but we will select the best idea ourselves. Okay? You have the monopoly in selecting the ideas. You can then run to a community model, right, which says that the ideas themselves will be generated from lots of people, and the selection also is going to be done by lots of people. So Threadless is a great example of a company in Chicago that does this for t-shirts, but open source software development is also done in this way. Then you can rely on other settings like a market feedback or a managed process as well. But the thing you want to sort of think about is, right, what's our perspective on the solution, right, where that exists, and what's our perspective on the use and where that exists, and that could help us inform what we do. So Jeff Davis and his group has basically taken some of their problems and has thought through, given the problems we have, where do they reside in this quadrant, right? And that helps them then think about what should we do inside, what should we be doing outside. Next slide, please. So I'm going to end with this. Actually, there's two more slides I want to end with. The first is, when you go in this direction, you're now going to be asking questions, right? You're going to be good at asking questions, right? And Bertrand Russell has this great quote, right? The greatest challenge to any thinker is stating the problem in a way that allows a solution, right? So asking good questions now becomes a skill, especially if you're going to go outside. Next slide, please. We'll skip that. Next slide, please. So what I want to end with is some work that I'm doing with NASA and with the Space Ops Group and Jason Kruzan. We have established a NASA tournament laboratory. It's a lab at Harvard where we're going to be taking challenges, computational challenges from within NASA across all centers and then running tournaments around them. Next slide, please. Basically, we have two main objectives. It's a joint venture between us, Topcoder, and NASA. One is to basically make an operational facility available for NASA folks so that they can take a problem, right, put it out to a community, get it solved, and get it back in, and then test it and make sure that that can be operational in a short order of time. And then from my selfish perspective, right, is I want to run experiments. I want to actually be able to do social science around this to understand what are the dimensions under which you would use a cooperative competitive regime, what are the dimensions of prizes and so on that come through as well. Next slide, please. This came about because with Jeff Davis, we ran a challenge for the space medical kit algorithm problem back a year ago. The results were spectacular, and that triggered some conversations here. And then there was a contract put out there that we were competitive with. Next slide, please. So this is our site. Everything that you see on the site was actually also developed by the community. So every single element here came through by contest as well. So Topcoder is very recursive in the way they do things. And we're currently running a challenge right now for some folks at Ames on image recognition. Next slide, please. And just to show you, next slide. Just to show you how powerful this is, basically, it's a vehicle recognition problem that allows for terrestrial imaging and detection of objects. In the space of the 3 weeks, we had 1,600 people register for this contest. 128 people have actually submitted code, and we received, as of yesterday, 446 code submissions. And close to 8 of them are reaching what we call perfect solution based on our test suite capability. So I'm going to end here and then take questions.
Okay, thank you, Kareem. Just another reminder that the presentation and all the slides will be available online on the OCT website, and we'll have that address up for you, and I'll give it to you again. We're going to be taking questions here at headquarters and by email from the folks that are watching from our various sites and on the web. For the questions here at headquarters, if you would please wait for the microphone to come to you. Please stand, identify yourself, and go ahead and ask the question. We'll start here at headquarters. And do we have a first question from anybody in the audience here? Don't be shy.
I'm used to cold calling too.
Going once? You got a gentleman in the middle here. Please wait for the microphone.
Just, I guess. Okay.
Sorry, what's your name?
Steve Davison. Quick question. I get the idea.
Yeah.
Okay. But I'm not quite sure what the limitations are here of this model.
Great question.
With respect to putting out what we call a broad agency announcement,
Yes.
which goes out to basically the country, ask for their ideas to address things. Competitive grants come in and are reviewed through our selection process
Yes.
to try to pick the best, most meritorious answer there.
Yeah.
Seems like there's a lot of parallels, and I'm not quite sure.
Yeah, so I think the question is, how does this compare to the BAA approach that many agencies in the U.S. use, especially NASA? I think two main differences. One is that the questions tend to be very broad, and you're not looking for solutions, you're looking for proposals for solutions, right? You're not looking for working technology. In this case, the questions tend to be fairly narrow, right? In the sense of, right, microgravity laundry machine, right? Or an algorithm for predicting space weather. Those are fairly narrow questions. So one is the narrowness is what you need. First of all. And secondly, it's not just proposals, you actually want working solutions. You want things that will actually work and you can put into practice right away. So that's the main difference, which is that they tend to be specific technological, scientific challenges, and they tend to be focused on solutions and not just proposals. Okay? And in terms of the broad applicability, I think what this requires, though, is a change in mindset to sort of say, we need to be able to be good at asking questions and to be able to modularize the questions so that we can take a space, chunk it up into many different components, and then run these challenges independently. Right? The other option is to do what XPRIZE did, which was like just create the plane that will fly, right? And then you'd leave that up. But then that will naturally limit who can participate. As you start to chop up the problem space into smaller components, more people can participate, and you get more knowledge from lots of people, lots of spaces.
Super, thank you. I think we have another question on this side over here. Please stand up and hold the mic close.
John Sullivan, you have talked about two things, this National Tournament Lab and incentive.
Yes.
Wondering a little bit about the difference between those two.
Absolutely.
And also what the breadth of things they can do. National Tournament Lab, you seem to have focused on algorithms. Is it limited to that, or is it can be used for a broad range of topics also?
Yeah, so the NASA Tournament Lab is both a research and a development initiative of NASA, and we're focused primarily on software-related problems because the software problems tend to be different from both in our ability to articulate them very quickly, as well as our ability to gather lots of people and get them engaged, than sort of more what I would call a fuzzier science problem or technology problem that we need more work around. So NTL, the mission for NTL is to literally create this vehicle that enables us to solve NASA computational problems through tournaments. Over time, we may build up the capability once the contract is evaluated, and it's a pilot program right now, to then assess and say, where else could this be done? Independently, NASA, primarily driven by what Jeff Davis has done, drove the work with Innocentive to basically create a challenge platform for other non-algorithmic problems. And so that work was done, and there's a pilot done as well last year for that.
Talk a little bit about SpaceX and what's a way to do a hardware-based tournament?
Yes, so I mean, I think that's a great question. I think you can imagine many ways to do that. You could build your own platform and create people to work with you, or you could use many of those platform providers that exist. So there is challenge.gov, which the federal government has set up now as well, or you could use Innocentive or other facilities as well for that. Yeah, and the Space Life Sciences actually had hardware components in terms of what they were looking for.
Okay, thank you. Derek, do you have an email question for us?
Yes, I have one from Ames. So you've been talking about the tournament labs and the innovation. So the question is, how does this all fit into the Open Government Initiative?
Great question. I don't think I'm capable to, because I don't speak for the government, I'm the right person for this. It's certainly consistent with what the Office for Science and Technology Policy and the White House has purported, which is open government. And what this does is one instantiation of this in the sense of we want lots of people participating with us to solve government problems. And this is certainly a set of government problems that we're trying to solve.
Super. Do we have another question from the audience here? Don't be shy. Okay, Derek, do you have another one?
Yes, I do, actually. Can you identify or point any other government agencies who are embracing open innovation platforms to engage their workforce?
Sure. So I think DARPA has done a bunch of work around open innovation, of course. You all probably remember the Red Balloon Challenge that happened last year. But I think Human and Health Services, of course, has run some challenges as well. But if you just go to challenge.gov as the website, you'll see a range of problems now put on this government platform to allow people to participate.
To repeat that, challenge.gov.
Yeah.
So
Absolutely.
again, everybody, that's a great website to take a look at. Do we have another question here at headquarters? Out there back in the back rows? Okay, Derek?
We have another question from KSC. Are there any innovative ways that NASA could further use collaboration methods that we don't today, such as those used by other companies?
Sure. I mean, I think NASA has actually, done a lot with collaboration, both in its willingness to sort of do these challenges, as well as what NASA has done with open source software. I think the question really is a change in perspectives. Like, can we think about across the entire space program, ways in which every single component within NASA thinks, should we solve it all ourselves, or should we engage the minds of others outside of the agency, right? Both in the federal government, but also across the country or even around the world. And sort of not starting with the default that we should do everything ourselves, right? We should, of course, define the questions and define the problems, right? But the question of, should we be doing everything ourselves? I think that should be an open question that NASA employees, administrators should be thinking about all the time, saying, how do we leverage, given this world of flat budgets, reduced budgets, right? How do we leverage the knowledge that exists? And for me, having now run 2 challenges for NASA as a sponsor of challenges, the enthusiasm, at least in the software world for NASA, is unbelievable. I mean, people just, for a NASA T-shirt, they will go crazy. They will work forever for you. And even more, they want to see that their solutions got accepted, that they got feedback, right, and that they're actually in use. And the fact that we were able to show in the first problem, the Space Medical Kit problem, that in fact the solution was viable, that NASA appreciated the answers, and they were then testing them right now, was amazing for the community. So I think there's an underappreciation of both the goodwill that people have for NASA, and also the ability for NASA to tap into all these people and work with them.
Okay, we have a question over here on the left side. Please wait for the microphone, and please stand up and go ahead and ask your question.
Hi, I'm Nancy Conrad. Who owns the IP when you put these challenges out and an answer comes back that is a great solution to a NASA problem?
Yeah. Are you a lawyer?
No, but I work with them.
You work with lawyers, yeah.
But I'm not in the office.
No,
but it's a
joking.
thing that we deal with because we have a national competition for high school kids.
Yes.
And we ask them to create products to solve real world problems.
Yes.
Those kids own the IP. We don't.
Yes.
So I'm just curious who owns the IP when in these sorts of scenarios.
That's a great. So in the commercial world, what we've sort of seen has been that it's basically about how you write the contracts, right? So in the commercial world, both with Incentive and Topcoder, when you give the prize amount, you basically relinquish your IP, right? So you transfer the IP over to the firm in return for the prize amount. And that's been the standard practice around. With government, there's all these issues around how that's going to work. Our solution for the tournament lab for software has been to, in fact, that we'll create an open source license for it in a way that is available to the community, but also NASA can use it for free as well. With the transfer of the prize as well. But that's really a design question. I mean, there's no hard and fast answer. It's really a policy and a design question. And as long as you are transparent about the contract, right, saying here are the rules of the game, right, and as long as you don't change the rules of the game, you're free and clear in designing your own IP regime around the way.
Thank you. Great question. Right here in the front row.
I'm curious, what do you think the implications are for the scientific community and the technology community in terms of norms in the tradition of Kuhn and Merton? When you have citizen science, how does that change the practice of science and technology by experts?
Yeah, so I think I've got a couple of doctoral students writing dissertations on this topic. So it's a deep question. It's a very deep question. Here's been what my experience has been, that there is a ton of skepticism about this. Scientists and organizations, large organizations, are reluctant to let go of the problems because they view themselves as problem solvers, right? Intellectually curious, and if they're stuck, they're going to work even extra hard on the problems. And the notion that somebody else on the fringes and the margins can solve the problem for them is again anathema. But when we track for people that have sort of taken the step and have done it, what they discover is what they say to us is that they've learned so much, because they never thought about the problem in all these myriad different ways. And so their knowledge base has now increased tremendously, right? Because I never thought of this problem this way or that way, and now I'm much more informed about this. Now, they may again narrow up and not release the next problem, but at least the experience of people participating, scientists and engineers participating, is that I just got exposed to a whole new set of knowledge that I never knew existed, and I can now think about applying towards my thing. But these are very, again, I'm not kidding when I said these are doctoral dissertation type questions, because it's not clear to us that the current establishment and the way we reward technical staff and scientific staff, both at universities and in organizations, is going to be receptive, hospitable to this way of working.
Derek, do you have another email question?
Yes, I do. Another question. So it sort of comes back to you said there's smart people everywhere. So how do you deal with the possible pushback from established researchers, the not invented here syndrome?
Yeah. Good luck. That's going to happen no matter what. I mean, I think this not invented here syndrome is real. And to some degree, there's two things, right? One is in large organizations, what we've seen has been that this is managerial fiat to some degree. Executives say this has to be done. In a company like Procter & Gamble, they said that everybody has to get half their ideas from the outside world. right? And they create an infrastructure that enables that, and all the performance bonuses, everything else resides on this edict. So you can be very top down and sort of say, this is the best, this is the only way to do this. And this is the only way that our firm is going to approach this. The other approach is to allow for prototyping, allow for small experiments to take place within the organization, and for the organization to learn how to deal with this, and then for it to be a bottom-up process as well. We've seen both. And certainly our approach within NASA has been to say, we'll take real NASA problems and we'll put them out there and you'll see the results. And then you decide if you want to use it more or less.
Okay.
Okay, thank you. Do we have any more questions here in the auditorium today? Okay, Derek, do you have another one?
I actually do. I have another one. Are there any innovative ways that NASA could further use collaboration methods that we don't today, such as those used by other companies that you've worked with?
Yeah. So I mean, I think as I discussed before, I think thinking through a systematic approach. So right now, these are small experiments going on, right? And should we be thinking systematically across the various programs, across the various initiatives at NASA? How do we think about using tournaments, using communities to solve our problems, right? And what's nice is that there are lots of large organizations that have tried these, and there's lots of lessons on how to organize yourself to do that. So I think NASA, through both its contractors as well as through its contacts in the industry, can leverage the knowledge of people that have run communities, talk about IBM, or run tournaments like Procter & Gamble or General Mills, and bring that in.
Okay, thank you. We've got time for a few more questions. Anybody here at NASA headquarters? Okay, Derek, give us another one from the
I'm
field.
getting flooded with emails. So it's sort of building upon your point about competitions and incentives. So the question comes back is, if I have a solution that is patentable and I would generate wealth for myself, why would I want to submit it to a committee?
That's a great question. I think what we see is that you shouldn't, right? If it's patentable, you should not. You should go get a patent on it and create a company around it. In most settings, though, what we find is that the individuals don't have what we call sort of the complementary assets to be able to take their idea, right, and make a company out of it or sell it. And so, again, remember, in all these settings, participation is voluntary, right? Nobody puts a gun to anybody's head and says, you must participate, you must submit something. You can walk out at any time you want. And so what we find are people participate because they enjoy the problem-solving process. They love what they're doing from this challenge, and they want, again, if we think that in the competitions we run for NASA, that the T-shirts matter as much as the prize money, what it is the fame and the glory to say, like, my solution is now in the space program. And so what we see is a natural sorting of people. Those that are sort of driven by the patent view won't participate, which is fine, but others that aren't driven by that will participate, and then that can be put to use.
Okay, super. Thank you, Kareem, and thank you all for the great questions here at headquarters and from the field. Just a reminder, for more information about this program and others that OCT works with, and to view a replay of today's presentation, all the slides, and the Q&A, please check out www.nasa.gov/OCT. Thank you, and have a great NASA day. Thank you, Kareem.